Yes, hopefully everything is good now. Fine. Okay. So uh, this is lecture number 17 of physics optional paper 2 for UPSC CSE, and for forest services I don't have any idea. Okay. So I am teaching here for civil services. I don't have any idea about forest services. So if someone of you is preparing for forest services, then he or she may do a research on herself or himself that whether this course which is going on right now is compatible with it. Is it going with the syllabus line or not? Line by line, is it going like that or not? Okay, you can surely check that. And even if there is a difference, now there will be very slight difference. There will be very slight difference if at all, if at all there is a difference, then it will be very slight difference. Okay, so don't worry about it. Okay, now lecture number 17, this is lecture 17, and if someone of you is new to the channel, then please watch the previous 16 classes, which the link of which I have already given in the description as well as in the form of comments. There is a full playlist of physics optional paper 2 UPSC. By that name you will get the playlist, and right from the first lecture you can watch the previous 16 lectures, and then you can surely come to the 17th lecture. Only then you can take the full benefit of this class. Okay, so now let us solve one more question. Okay, this is not your PYQ, this is extra question which I am giving. Okay, the wave function of a particle, the wave function of a particle at a given time. Okay, at a given time. Okay, the wave function of a particle at a given time is, at a given time the wave function of a particle is written like this. This is basically one dimensional Schrodinger time independent wave function. Okay, one dimensional Schrodinger time independent wave function, because it is a small psi instead of capital psi. It is small psi, right? So instead of capital psi it is small psi, and over here no t term is present, so that's why it is time independent. Okay, when t term is present it is time dependent, and time dependent is represented by capital psi. And what is the difference between the notations capital psi and small psi? I have already told you. Okay, what is the difference between the notations of capital psi and small psi? I have already told you. This is for all 0 x l. Okay, 0 x belonging to 0 to l, and this wave function will become 0 otherwise. Okay, otherwise means for values of x, for values of x other than 0 and l. Okay, for values of x other than 0 to l. Okay, this wave function will turn to 0. Okay, don't worry about this notation. Okay, don't worry about this notation, don't pay any attention to it. I just wrote that expression like that only, without any reason. Okay, so 0 to l, this x is belonging. Okay, so and it is otherwise 0 in the values other than 0 to l, and in this also 0 and l are not included. Okay, over here equality sign is absent, right? Over here equality sign is absent. So what does that imply? That simply implies that 0 and l are not allowed. In between 0 to l everything is allowed. In between 0 to l everything is allowed, but 0 and l are not allowed. That is the meaning of that. Okay, so wave function of a particle at a given time is given like this, and it is 0 otherwise. Find the probability of finding. Now look over here, we have to basically the probability find the probability of finding the particle in the range, in the range l by 4. Okay, x 3l by 4. Okay, so this is the question which is given to you, and such questions are frequently asked in UPSC exam. Okay, so this is the thing. Now we know that the formula, wave function is given like this for 0 to l, otherwise it is 0. So clearly you can see one thing, that this l by 4, this limit l by 4 to 3l by 4, right? It is from l by 4 to 3l by 4. So if it lies over here, then clearly which formula will be applied out of these two? Which formula will be applied out of these two? So clearly you can see this thing, that l by 4 to 3l by 4, that simply implies that it will lie here, because this limit 0 to l will include your l by 4 and 3l by 4. Okay, so the you look something like this. Okay, this is 0 to l, and over here it will be l by 4, over here it will be 3l by 4, right? So your entire limit lies over here, your entire limit lies over here, so it is included within this limit is included over here. So as it is included over there, you can clearly find this thing. You psi of x will be defined like this. It will be defined like this instead of 0. So this thing you can simply ignore. Okay, it is not necessary that in every problem it will happen like that only, but in this particular problem, with the first definition of the psi x only, our question was made. Okay, our question was being solved. Okay, so clearly your probability will come out to be, you know this very well, that it will be l by 4 to 3l by 4, right? L by 4 to 3l by 4 psi star x, right? Psi star x, psi x dx. Now how this formula came, I already told you in the previous class. If you haven't watched the previous class, then I can't help you out with this, because this formula, how this formula has come, I have already discussed in the previous class. So directly I am using the formula. Okay. Now you will basically substitute the value of psi x over here. So what will you get? As this quantity psi x does not contain any imaginary thing, no iota term is present in it. No iota term is present in this box expression, the expression which is there in the box. In it, no iota term is present. No iota term is present means we will not replace minus I by I. As no iota term is present, so its conjugate will be equal to this only. Psi star will be equal to psi only. As no iota term is present in it, it is real term. That's why. So you will basically substitute the values over here. This is L by 4 to 3L by 4. Okay. Then what will happen? This is L by 4 to 3L by 4. Okay. Then psi star. What will psi star become? Psi star will become square root of 2 by L. Okay. Sine pi x over L. Then again it will become basically its square, right? It will become its square dx. Okay. Then what will it turn out to be? It will simply become 2 by L, because this root 2 over L will become 2 by L. So it is a constant, so it will come out of the integral. L by 4 to 3L by 4. Okay. L by 4 to 3L by 4 sine square pi x over, not complete over L. This term is inside the okay. This is like this. Okay. Over L is over here. Okay. You can see over here. Okay. So over L is over here. Okay. So now you know this very well, that sine square theta, the formula for sine square theta is equal to 1 minus cos 2 theta. You might have learnt in your lower classes that sine square theta is equal to 1 minus cos 2 theta. 1 minus cos 2 theta. So you will substitute theta equal to what you will substitute? Pi x over L you will substitute over here. So basically you will get this to be equal to uh, no, this should be 2 times, right? This should be 2 times. So this formula you have learnt in your lower classes. So clearly you will get 1 over L. Okay. L by 4, 3L by 4. Okay. Sin square pi x over L will become basically 1 minus cos 2 pi x over L. Okay. 2 pi x over L it will become. Okay. And then dx will come over here. Okay. So then you will solve the integral. I don't want to go into that. That is very simple. 1 over L. Then this will become x minus L by 2 pi, and etc. etc. It will come. Okay. And you will get the final answer. Okay. After you solve all these things, you will basically get, L will cancel out. In the final expression, this L term is going to cancel out. And after the cancellation of that L term, you are left with 1 over 2 plus 1 over pi. You are left with this. And 1 over 2 or 1 over pi is simply equal to 0.82. Okay. So this was the problem. Okay. So easy was the problem. Okay. Got it? Now I would like to discuss over here something, that over here our limit of x, was L by 4 to 3L by 4, right? Our limit of x was like that. And this function, let me write again. This function, this wave function psi of x, okay, it has been defined like this: sin pi x over L, okay, for 0 to L and 0 otherwise, right? 0 otherwise. So what will it turn into? Over here we had to find the probability of finding the particle. We had to find the probability of finding the particle in this range. Okay, and you can clearly see this thing, that this entire range lies over this only. Okay, inside this limit is contained within this. So you have only one definition of psi of x. Zero definition didn't come in your expression. Okay, but what if suppose minus L by 2 to L by 2 is the limit. Suppose instead of L by 4 to 3L by 4, suppose the limit is minus L by 2. Suppose the limit is minus L by 2 to 3L by, not 3L by 2, plus L by 2. Okay, minus L by 2 to plus L by 2 is the limit, suppose. Then what will happen in that case? In that case, the 0 to plus L by 2 part, okay, 0 to plus L by 2 part will open with this, and below 0, whatever things will be below 0. Below 0 means minus L by 2 to 0. This term will simply open with 0. So that term will vanish, and only 0 to L by 2 will be taken into consideration, because the wave function for 0 to minus L by 2, minus L by 2 to 0, the wave function has turned out to be 0. Okay, so I am giving you the homework for the same wave function. Okay, for the same wave function which is given over here. Okay, for the same wave function sin pi x over L. Okay, for 0 x L. Okay, and 0 otherwise. Okay, so for this same wave function, find the probability of finding the particle. Find p. P is equal to what? For your x belongs to minus L by 3 to 2L by 8. Okay, you have to find in this region. Okay, so whatever answer will come, you will have, you can basically you can WhatsApp me. Okay, you can WhatsApp me its answer, or you can get it checked by me. You can get it checked by me on this WhatsApp number. Okay, and I will reply to your doubts on 7th of September. I will reply to your doubts on 7th of September. Okay, so you can message me on WhatsApp the solution of this. Okay, the same problem, but for limit minus L by 3 to 2L by 8. Okay, you will have to solve it and show it to me, send it photos to me. I will check those. Okay, so thank you very much. जय हिंद जय भारत. अपना ख्याल रखें और टेलीग्राम ज्वाइन नहीं किया है तो कर लें. ओके.